Hi everyone. In this video, we're going to be talking about series and parallel circuits. Now, let's look at the first circuit that we have here on the left. For this circuit, it is a closed loop circuit. When the current flows out of the voltage source, alright, so let's call this current I1. It flows through the resistor R1. After it flows through the resistor R1, the same current flows through the resistor R2. And the same current also flows through the resistor R3. So when you have the same current flowing through different components, then we say that those components are in series. So the total resistance is given as R1 plus R2 plus R3. So this is the formula, okay, for a series combination of resistors. Now let's look at the circuit on the right. Over here, again we have a closed loop circuit, and when current flows out here, so let's call this I. At this point, okay, at this first junction, you can see that the current will split. Okay, now before we go into further analysis, you can see that the junction here and this junction here, all right, there is actually no component here. That means this is actually a short circuit wire. All right, and similarly from here to here where we connect the other resistor is also a short circuit wire. The same thing for the other end of the resistors over here. All right, so in terms of circuit connection, you can say that since this is a short circuit connection, you can think of all of this as a common point. All right, that means I can actually sort of redraw my circuit, okay, to make it look like this. Okay, where all three sort of split up from the same point and then pass through three different resistors, R1, R2 and R3. Okay, so with that you can see that it's easier to see that when the current comes out of the source at a common point over here, it splits into three different currents. So we can call it I1, I2 and I3. Okay, it splits into three different resistors. Okay, so you can see it a bit more clearly if I draw it over here. Okay, but it's the same thing. Okay, what you see over here on the left and right, they are both the same circuit, only thing drawn differently. All right, so in this case you can say that since the current I splits into R1, R2 and R3, you can say that these resistors are in parallel. Okay, and for parallel resistors, the formula is given as such: 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is for the resistors in parallel. Now let's look at a circuit that has a combination of both series and parallel. Now in this circuit, okay, let's again analyze it from the current perspective. When the current comes out, okay, we call this I, it flows through R1. Okay, but at this point over here, there is a split into two separate resistors. So we call this I1 and I2. So since there is a split into two resistors R2 and R3, we can say that R2 and R3 are parallel to each other. Okay, so that is always the easiest way to analyze it. Whenever there is a split in the current from a common point, then those components are parallel to each other. Alright, so if I want to simplify this circuit, okay, the first step is I would have to redraw the circuit such that I have a voltage source, resistor and I have the combined resistance. So this will be V, this will be R1, and this will be R2 parallel to R3. And now if you analyze it again from the flow of the current that comes out of the source flows through R1, and that same current flows through this R2 parallel R3. Alright, so since the same current flows through these two components, you can say that these two are in series. Okay, so the combined resistors in this case, okay, the RT would be R1 in series with R2 parallel R3. Okay, so that would be the total resistance for this circuit. Okay, so I hope with this video you are clear on how to analyze a circuit to better understand what are the components that are in series and what are in parallel. Thank you for watching. I'll see you in my next video. Bye.